So for now, I want to conclude this course by looking at a little bit about climate anxiety, which has become a bigger and bigger problem. So this is taking the temperature. Nature asked readers how worried they are about climate change and whether their fears are growing and how hopeful they are about the upcoming COP26 summit. So this was done before November 2021. You can see extreme concerns, growing fears, and hanging on to hope. 650 respondents from, good sampling. Extremely worried is quite high here. Growing fears, so increased a lot since the Paris Agreement in 2015, which is not good. So more and more bad news, alarmist news, if you can say. Sometimes climate disasters, extreme events are beginning to worry people, especially the young ones. Hanging on to hope, just under half the respondents are hopeful that the upcoming COP26 meeting will significantly boost global efforts to tackle climate change. So somewhat hopeful about 40%, not hopeful 46%. So this is not good because already the fight or flight response or freeze response is being to kick in. Good things happen when we are in the parasympathetic nervous system, if you know what that means, not the sympathetic nervous system. So rest and digest brings mindful actions, decisions, thought processes. So climate change and the scary future ideas need to be more carefully portrayed and not overhyped sometimes, as it tends to happen. Let's finally look at the geoengineering methods, which are likely going to be part of the solution overall to meet our global warming targets, at least some of them. So forestation is one we talked about. CO2 capture from air plus storage, so it's called CCS or CCUS, carbon capture, utilization and storage. Many methods are being tried. Carbon dioxide is only 0.04% of the concentration in the air, so taking that out is very difficult. But at point sources like where coal is being burned, fossil fuel is being burned, or maybe even a car, it's possible, and concepts exist, and artificial tree concepts exist, and so on. Nothing scales up to the extent to make a big dent yet, but there are many good ideas that hopefully will become a game changer at some point. So this is CO2 capture from fossil fuels plus storage, so at source rather than from a distributed air capture, direct air capture. Ocean ion fertilization, basically without going into too many details, there are micronutrient deficiencies in the ocean. So even when macronutrients like nitrogen or phosphorus are available, photosynthetic organisms are not able to use them to photosynthesize and capture carbon because there is not enough iron available. It's just like us having iron deficiency or sodium deficiency and so on. The phytoplankton in the ocean also need all the minerals and nutrients. So it's shown that dumping iron that can become bioavailable does enhance productivity and carbon drawdown, but there are many details, caveats in terms of whether that carbon additional photosynthesis actually gets exported to the bottom of the ocean so that it's sequestered away, or if it just gets recycled and re-released, and whether additional photosynthesis leads to additional grazing and oxygen consumption and so on and so forth. There are ideas of cloud seeding and changing optical properties to increase the albedo, so reflective aerosol pumping in the stratosphere directly is pretty much going to be tried soon, at least at a small experimental scale. The analogy is from the aerosols during a volcanic eruption. When we put aerosols into the stratosphere, sulfate aerosols for example, they can reflect a lot of the sunlight, but volcanic eruptions also cause other problems like droughts and lack of sunlight, reduction in crop yields, global cooling, and so on and so forth. And just because you put aerosols in the stratosphere and reflected sunlight, it doesn't remove carbon. So ocean acidification, coral deaths and so on, and other bad effects of emission will continue. Plus, when you stop the aerosol injection into the stratosphere, there will be a recovery and rapid warming will come back. So those kinds of caveats have to be worried about as well. Less damaging but similar problems with not reducing CO2 is idea of space mirror to reflect sunlight away. There are ocean CDRs or carbon dioxide removal ideas as well. Many of them including enhanced alkalinity, biochar, where you convert organic matter and spread it on soils, accelerated weathering, where you grind up rocks like olivines and spread them on soils, and that will take up more CO2. So the geologic time scale weathering processes can be accelerated to draw down CO2, but they have to be net neutral. They cannot put more carbon than they are taking out in terms of grinding the rocks, transporting them, spreading them, and so on. So plus what happens to the soil quality, water quality, etc. So all kinds of details exist in geoengineering methods that need to be understood. But there is pretty much an agreement now that some sort of a geoengineering will happen to meet the global warming targets. So I have an entire course on is geoengineering inevitable, where I've used several books to go through these pros and cons and the methodologies of geoengineering that you can look up. I just want to kind of conclude with a couple of videos I found on WhatsApp. Don't know who the owners are, but I found them to be cute. So here, how do I make it play? The play button here has disappeared. So, oops. Let me see if I can. Yeah, there it is. So why can't I see it when I go in the there it is. Okay, so adaptation to climate change will be empirical. So these elephants suddenly face this problem of having to go down this ditch. The older one did it quickly and went away. The younger one is struggling, but empirically came up with its own method of crossing this ditch. So look at the way it managed. So climate adaptation is going to be largely empirical as well. We don't always know how to plan for the future, and as we said before, maladaptation can be a big problem as well. So that's something to keep in mind. Another funny video I will use is this one where a turtle is scaring the lion. So let's say lion is the climate change planet we are poking with a stick, but if we find the solutions, remembering the tortoise and the hare allegory of how the hare lost the race to the tortoise by being overconfident, but if we are not overconfident and we systematically solved the climate change problem, then maybe we will scare away climate change. So just a funny way to end this part of the course. So the turtle is just calmly swimming up to the lion. The lion isn't sure what's happening, so he stops, he looks at it, and doesn't know what to do, so moves to another place to drink. But the turtle is bravely chasing the lion. So there he is again. What's happening? So this is human beings if they are confident about solving the climate change problem. I don't know, just a kind of a funny video that I found. Don't know who it belongs to, but I thought I'll include it just to end it on a humorous note for this section. So I'll come back and add the next section on Introduction to Modern Climate Change from Andy Dessler's book. Andy Dessler, who's at Texas A&M University in College Station. So Already we addressed many of the climate change issues here, so I'm just going to add few points from that book that are not included here, just to kind of complete the introduction to climate change. Again, remember that this is supposed to be at an introductory level, so I'm not going to go into tremendous details. If you want the details, you will have to look up my other courses or read other papers, books, and so on. There is obviously infinite amount of material available, so when you choose to teach a course, you always have to kind of prepare your own set of the material from books and papers and so on, which is fun, but it cannot be comprehensive, so you have to fill in the gaps you perceive on your own. Okay, see you in the next section.